You're standing in a field, 10,000 years ago. Storm clouds are rolling in, lightning cracks across the sky. Violent, blinding, and absolutely terrifying. You drop to the ground like a sensible person. And then, just before you cover your head, you notice something. The lightning doesn't disappear. It travels, down from the sky, into the earth, through everything in between. And for a brief, insane moment, you think, what if I could do that on purpose? What if I could take that energy, tame it, shrink it, and make it flow exactly where I want it to go? You look down at the rocks under your hands. Nobody in the history of the world has ever looked at a rock and thought, phone charger. You're about to be the first. Step 1, and you know this by now, don't die. You cannot discover electromagnetic induction while also being struck by lightning. So you find food, find water, learn fire, survive. Weeks pass. Then, the thing that makes all invention possible finally arrives. Free time. Quiet. Unhurried. Nobody needs anything free time. And free time, as always, is the only raw material that has ever mattered more than rocks. Now you can think. And the first thing you think about is that rock in your hand. Not all rocks are the same. Most are useless. Granite, limestone, sandstone. But some rocks have something inside them that nobody has named yet. A greenish, bluish, sometimes reddish rock that feels heavier than it should. When you chip it open, it has a strange metallic sheen inside. It catches the light differently. Something is hiding in there. That rock is copper ore. And it has been sitting in the ground, completely ignored, since the Earth formed 4.5 billion years ago. You are about to change that. You build a furnace, not a campfire, a proper, serious furnace with clay walls thick enough to hold heat and bellows to drive the temperature up. You pack the copper ore inside and burn charcoal until the temperature climbs past 1,000 degrees. At that heat, something happens inside the furnace that has never happened by accident in nature at the surface of the Earth. The rock stops being rock. A liquid pools at the bottom, red gold, glowing, flowing like a slow, heavy water. You pour it into a mold. You let it cool. What comes out is copper. Pure, soft, endlessly useful copper. The most electrically conductive natural metal on Earth. You can beat it thin. You can draw it into wire. You can wrap it around things. It bends without snapping, and it conducts electricity better than almost any material that exists. You should feel proud. You have just smelted metal from rock, using nothing but heat and patience. That is genuinely extraordinary. You should not feel completely proud yet, because raw copper sitting in a lump does absolutely nothing useful. What you need is to understand what copper actually does. And to understand that, you need to see the thing it does best. This is where it gets strange. You have your copper, you have your rocks, and then one afternoon, you are experimenting, wrapping copper wire into coils, moving a piece of lodestone back and forth near it, watching for any reaction. When something completely unexpected happens, the compass needle twitches. Not when you touch it, not when you breathe on it, when you move the magnet near the copper coil. Nothing is touching, nothing is connected, and yet something invisible is passing between them and making electrons in the wire move. You have just discovered electromagnetic induction, the same discovery that Michael Faraday made in 1831 when he moved a magnet in and out of a copper coil and watched a galvanometer needle swing. The same discovery that gave the world generators, transformers, wireless charging, and every single electrical device that has ever been plugged into a wall. You did it with a lodestone and some copper wire and an afternoon with nothing urgent to do. The rule is almost insultingly simple. A moving magnetic field through a copper coil creates electricity. That is it. That is the whole secret. Every power plant on Earth, coal, gas, nuclear, wind, hydro, is just a very large, very expensive way of spinning a magnet inside a copper coil. The charger you plug into your phone every night is a very small, very cheap version of the exact same idea. But here is the part that makes this discovery almost unfair in its implications. You did not just discover how to move electrons through a wire. You discovered the mechanism behind every form of electrical power that humanity will ever use. Every single one, without exception. Coal power plants burn coal to boil water to spin a turbine, which is a magnet spinning inside copper coils. Nuclear power plants split uranium atoms to boil water to spin a turbine, which is a magnet spinning inside copper coils. Wind turbines catch the wind to spin a rotor, which is a magnet spinning inside copper coils. Hydroelectric dams send water through a spinning generator, which is a magnet spinning inside copper coils. Solar panels are the only major exception, and even the electricity a solar panel produces has to pass through a transformer, copper coils around an iron core, before it reaches anything useful. The entire electrical civilization of the modern world is one idea, expressed at different scales, in different materials, in different contexts. Your idea, the one you just had in a field with a lodestone and some wire. Faraday figured it out in 1831. He was the son of a blacksmith. He had no university education. He taught himself science by reading books in the shop where he worked as a bookbinder's apprentice. When he demonstrated electromagnetic induction to the Royal Institution in London, a politician in the audience asked him what practical use it could possibly have. Faraday looked at him and said, and this is essentially what he said, "I don't know yet, but I suspect one day you will tax it." He was right. You pay an electricity bill every single month because of what you just discovered in this field. Every city lit up at night, every hospital running on power, every factory, every server farm, every electric vehicle charging in a driveway. All of it is a magnet moving near copper wire. You just proved that. With a rock and an afternoon. Here is what that charger is actually doing. The voltage coming out of your wall is too high and too wild for your phone battery. Your phone needs steady, tame, controlled power. Roughly 5 volts of direct current. The wall is giving you 120 volts of alternating current that swings back and forth 60 times per second. Put that directly into your phone, and the phone dies. Immediately. Dramatically. So the charger sits between the wall and the phone, and does 3 things. First, it transforms the voltage down. Inside the charger is a tiny transformer, 2 copper coils wound around a small iron core. The wall voltage enters the first coil, creates a magnetic field in the iron. That magnetic field creates a new current in the second coil. And because the second coil has fewer turns of wire than the first, the voltage that comes out is much lower. This is pure Faraday. Moving magnetic field. Copper coil. New electricity at a different voltage. The iron core comes from iron ore rocks, the same iron that has been sitting in the ground since the Earth formed. Second, it converts alternating current to direct current. A set of tiny components called diodes, made from silicon, which is refined beach sand, allow electricity to flow in only one direction. They are the traffic lights of the electrical world. Alternating current goes in, direct current comes out. The silicon diodes came from the same sand you have been standing on this entire time. Third, it smooths the power. Capacitors, tiny components that store small amounts of electrical charge, absorb the bumps and wobbles left over from the conversion process and release a clean, steady stream of power. The result is exactly what your phone needs. 5 volts, smooth, controlled, safe. Every component in your charger, the copper coils, the iron core, the silicon diodes, the capacitors, came from rocks and sand. The principle moving electrons through every one of those components was discovered by a man moving a magnet through a copper coil in 1831. A bookbinder's apprentice. No degree, no funding. Just curiosity and a piece of wire. Most people think a phone charger is a piece of modern technology that came from a factory and a design team and years of engineering. It is all of those things. But underneath all of that, it is a small piece of copper or rock wound into coils around a piece of iron or rock, with a wafer of refined sand telling the electricity which way to go. You started with lightning in the sky and rocks in your hands. You are ending with the device that lets you charge your phone, watch your videos, call anyone on the planet, and if we're being honest, scroll through things at midnight when you should absolutely be asleep. The lightning didn't disappear. You just finally gave it somewhere to go.